at Lenaro Connect. We're in Redwood City, California. We're here planning, at another quarter, planning the future of what we're going to be releasing and doing all those things. David, and I'm here with David Mandala, and you're the Ubuntu ARM team manager for Canonical?
Indeed I am.
David, I wanted to interview you here at Connect because recently you gave an interview about Ubuntu ARM at LinuxConf AU, and you talked about going from the netbook to the server. Can you tell a little bit about the history of that? What were some of the challenges in doing that?
Sure, I'd be happy to.
Okay.
We started with Ubuntu about a little over 3 years ago, going from strictly an x86 distribution to covering ARM as well. Of course, we derived from Debian, so it was a little easier than some distributions have had to move to ARM, but we chose to do some things differently than Debian did. So we chose that we'd go with ARM v7, the higher end cores, instead of the ARM v4 cores that Debian handles. We also decided we would cover SMP, floating point, and other things that were in the newer cores. And that turned out to be quite challenging. It was, first we had challenges of just getting hardware in order to build on, because Ubuntu is native built, so I have to build on the actual hardware that I'm going to run on. And the other problems were, in some software packages, when we went to do SMP and started running into bizarre problems when things were running, we discovered that people had made some assumptions in the day, and they did SMP for x86, then they did SMP for 64-bit x86, and then there were comments in the file, there'll never be SMP on ARM, why bother? And absolutely no memory protections or anything were implemented for ARM. So things were just kind of running and colliding with inside of these applications. So we had a lot of fun finding things like that. We also compiled for what's known as the Thumb 2 mode, which is a 16-bit mode on a 32-bit ARM RISC chip. And we were the very first distribution to compile over 20,000 applications for Thumb 2. And that ran into some interesting challenges as well, because if it's written in C code or C++, the compiler takes care of going from Thumb 2 to normal ARM. But if you've written assembly code, there's the problem. And so in certain cases, what was safe assembly code on a uniprocessor and what was safe code on regular ARM compilation was no longer safe code under SMP and under Thumb 2. So we had to go through and find all these handcrafted bits of assembly code and fix many places where these type of things were a problem. So those were kind of the general problems that we found trying to get Ubuntu completely compiled from x86 to ARM and do it safely for SMP and for the Thumb 2, Neon, the whole bit. So there were some definite challenges. And of course ARM kind of helped with challenges because when I say Neon, that's a math coprocessor, and they made it optional. So not all ARM v7 processors have Neon, so therefore I couldn't just default compile for Neon because anything that doesn't have it would just crash. So we had to put Neon in libraries and be able to, on runtime, determine if the CPU had Neon or didn't have Neon. And that, then of course there were different processors that had bugs with Neon, so we got kind of involved even getting Neon working. But we've got most of that sorted out, and now we're looking at ARM servers, and it's kind of an exciting world.
From what I can tell, you're one of the very first distributions to really look at like Linux ARM servers. That's really that's making, I guess, you're hitting mainstream news. People are talking about you. The end user knows about it. I'm sure there's others that are, behind the scenes or enterprise level and that kind of stuff. But as far as like everyday users, they know about this. I mean, they're aware of it. How do you think Ubuntu, in combination with some of the tools that Lenaro gives you, that you guys use, how do you think you're changing the world with that?
Well, let me say something to make something very clear so I don't upset a lot of distributions. We're the first commercial distribution doing Ubuntu ARM and server, but Debian, who we derive from, is interested in server and supporting that as well. So I just want to be clear, there are community-based distributions that are looking at server, but we are the first commercial distribution that will have commercial support behind it, and I just don't want to have that not mention the differentiation, because I really don't. To be fair, we've derived a lot from Debian and gotten a lot of help from Debian. Much like we have with Lenaro, we've worked very closely with Lenaro and ARM to get the right tool chains in place. We're switching to the HF tool chain, which is Lenaro has been working very hard to get solid. And that makes a huge difference. I mean, by switching from the old ARM EL format, which was the old soft float format, to the ARM hard float format, we're seeing a 3 to 5% general speed up in all software and up to 30% in throughput on things that actually use floating point. So how are we changing the world? We're making it a lot easier to get ARM things. I mean, in the past, ARM was a deeply embedded space. I mean, it's in your cell phone, it's in elevator controls, it's in cars, refrigerators, but those were all deeply embedded distros. Things weren't being pushed upstream. They were all one-off distros. You'd make this distro for this CPU and a different distro for another CPU. We're doing a general purpose full operating system. It's exactly like on the x86 side, except we're doing it for ARM. And it's a different kettle of worms to do that. And I think it's really exciting because it's making a lot of people aware of ARM. And I think in the server space now, it's going to be a huge win because with the power savings that comes along with ARM, there's many high density data centers that cannot get any more power. Physically, they just can't pull power in. So you can't build a data center any bigger, you can't put any more computer processing in it. But with ARM, you may double, triple, quadruple, or more the amount of data capacity. Plus it reduces the cooling, so you save money, it's greener, and you get much more computing capacity in the space. How it'll all play out, it's a little early to tell, but it's pretty exciting stuff today.
David, thank you so much for kind of explaining that there are other community builds of ARM servers and distributions that are working on that, and that it is important. And you are correct that any part of Ubuntu does stand on the shoulders of those giants and Debian. So not to overlook them at all. They are some brilliant minds at work there. I appreciate you stopping by and being willing to speak to me today, and I'm looking forward to seeing where the future of this goes. So thank you so much.
It'll be interesting. I'll toss one last thing. If you look at the LinuxConf AU website, they've got the presentation I made down there in full, and there's some videos of it too. So anybody who's interested in like the whole thing, go have at it. It's some really good stuff to look at.
Thank
you very much.
Thank you.